So as part of that, we also have the defect priority. So defect priority is something like we have test priority. So for us to know which test case to execute first, which one need to be passed first, which one can be done later. So the same thing goes when it comes to defect management. So for a development team to do their debugging later, we as the tester who do the testing, who identify the defect, we know better how is the criticality or how is the severity of the defects which we identify. So for us to let the developers to know which one we need the defect to be settled first, so that we can continue with the for us to continue with the testing. So we need to give them the priority level. So the development team know which defect they need to debug first, which one they can do later. Okay, so under the priority, we have three different level of priority. The first one is high, the second one is medium, and then the third one is low. So when we set high priority, due to that defect, okay, we cannot continue with our testing. So it means we cannot proceed with the testing until that particular defect must be fixed. So it means maybe any of the functionality, which is the main functionality, where the functionality must work so that we can continue with other functionality. So if those kind of functionality have a defect, it means we cannot continue with our testing. Okay, just ignore about the development. Okay, so the further testing cannot be continued until that particular defect must be fixed. So this type of defect, we must give the highest priority. So when we set high priority in our defect reporting, the development team will know that, okay, this is the one they need to work on first. Okay. So the medium priority is lower than the the high priority, where the defects still need to be solved as soon as possible. Okay, they cannot delay it. As soon as possible, once they're done with the high priority types of defect, they can move with the medium priority defect. But the difference here is it is not stopping us from continuing with the testing, because we can do it in a parallel mode. So while the development team doing the debugging, we can actually continue with our testing. So once they're done with the fixing of the defect, then we can just update with it. So compared to the high priority, which will stop our testing activity, medium priority, where the defect will not stop our testing, we can still proceed, but it still need to be solved as soon as possible to avoid any delay happen later. Okay, then the third one is the low priority. So low priority means after they have done with the high priority, with the medium priority levels of defect, then they can go with the low priority. So this is something very mild severity, and it can be done later. So this will be the three different defect priority level. Clear? Can understand? Okay. Any questions so far? So hope clear with the defect classification, which is the showstopper, the critical and non-critical. This is to let the development team to know where is the classification of defect which we identify, and then this will be the priority level which they need to follow for them to do the debugging, so that it will not give problem to our side. It means it will not cause any delay or any issue to our testing process to continue. Okay, can understand? So the next part here is the test report. Okay. So as what I have mentioned in our chapter 8, so there will be some report which I will discuss with the template in chapter 9. So part of it is the test report. So test incident report. So I have discussed about this incident. What is this incident? During the testing activity, when we need to prepare test incident report, what is the mean of this incident? Is it only about the defect? Is it only about the defect? Actually, when we said any unexpected incident, okay, it means we don't expect this and something else happen. Okay, so we can call that as the incident. So normally it can be defect. Okay, defect is also part of the incident. Okay, where I have my expectation result. Am I right? We already know the expect result, and then when we do our test case execution, we know our actual result. So when we say defect, defect means when these two they are not tally. It means I expect A but I see A minus. So it means they are not tally. When my actual result and the expected result is not tally, then we call that as defect. So incident is also referred to the defect. But at the same time, any unexpected behavior of the system or any unexpected response. So normally it's not only about the result, but suddenly something happened to the system because it is not what we want to see, but something happened. So any unexpected response from the system or any unexpected behavior, for example, there is some lagging happen, there is some hanging things happen. When we do this step action, the system is not responding and something else come up. So anything unexpected, we still call it as an incident. Okay, so it's not only about unexpected result of the test case, but also any response or any funny behavior happen during the test execution, we call it as an incident also. Okay, so when we identify or when we deal with this incident, we need to prepare this test incident report. So I have discussed about why we need to do this test incident report last week. Okay, so this report is actually a written description of what incident happened. So it means we expect something and something else happen. So when there is a gap in between that, so it means it's something which we need to put in a written description, because it might be due to the coding, it might be due to the development, or it can be any reason which caused that incident. So when there is incident happen which can give problem to our testing, as how we have mentioned in our test plan, so we need to put it in a written to show that there is something else happen during our testing. Okay, so that's what we call as a test incident report. So we need to mention what incident happened and how it's happened and how it can cause the impact. So normally when we said incident, we are referring to the negative incident happened. There is no positive incident here. Okay, So I will show you example of the template using the IEEE 829 standard test incident report. So something like this. Okay, so for your assignment, this is not part of the documentation you need to prepare. So normally during the test execution, okay, we already discussed what are the type of documentation which we need to prepare before the testing, during the testing, and at the end of the testing. Okay, so this test incident report is actually during our test execution. So when we are doing the test execution, there is unexpected incident happen, so we need to report them. So this is just one standard template, which is the IEEE 829. So where the test incident report will have a unique identifier, okay, then we will prepare the summary. So summary of the actual incident happened, and then the reference related to that incident, for example, our test case or our test procedures, okay, which we use and then discover the incident, and then test log, which is showing the execution of the test case. So test log I have discussed in the previous chapter. Then the second part is the incident description. So incident description is detailed explanation of the incident happened, okay? And then what is the input? It means the test data we are using for the test execution, and what actually we expect. So it means what the system supposed should do, what is the expected result, and then what is the actual result happen, and then what is the anomalies happen, and then the procedure step. So normally how we are doing the execution of that particular test case, and then the last part will be the impact. So when we said negative incident, it means it's going to give us an impact, especially it might cause how to say the plan testing to move from what we have planned. Sometimes when it's only defect, it might not really have that terrible impact, but when it comes to any unexpected behavior, for example, suddenly the system crash when we do this test execution. When a system crash happen and it's disturb the test environment, or something else happen until like we cannot proceed with the testing on that date. So it means it caused a big impact to our entire test planning. So it means it might cause delay in our test schedule until the system can be fixed, or until the test environment can be fixed again. So we need to explain, or we need to report what is the impact. So based on the incident happen, what is the damage cost? Okay, so from here, what is the severity, and then the priority of the assessment. So let's assume if the impact or the severity is very high for our testing, so automatically the assessment priority need to be on the high, so that we can fix this issue or this incident as soon as possible, so that we can proceed with our testing. Okay, so for every incident happen in our test execution, we need to come up with the test incident report, because this report will be the proof of why you cannot follow 100% what you mentioned in your test plan. I think last week I have talked about this. We plan 100%, but how many percentage we able to follow from the test plan? And let's assume the balance percentage of the changes happen due to any incident, any unexpected thing, or any risk. You need to have a proof what happened. So test incident report is actually the proof of what incident happened, what is the impact, and how it's actually going to bring changes to the test plan. So this is the proof. So that's why every single incident must be reported. Okay, so this test incident report need to be prepared during the testing. Okay, so the next one is the test summary report. So test incident is actually during our test execution, while test summary report is actually at the end of our testing. So it means we have started our testing, we go on with the testing. So now we end the testing. So we need to produce the test summary report. So this is to summarize the entire testing what you have done. Okay. So this will be produced at the end of our testing. Then this will be describe the result, what we get from our testing. So we will summarize the entire result for the testing. Okay. So this is a template which we can see for IEEE 829 standard test summary report. Okay. So the test summary report has the identifier. Okay, I will talk one by one. So we have the identifier. Every single test documentation must have unique identifier. Okay, then the summary, the variances, and then comprehensive assessment, summary of result, evaluation, summary of activities, and approvals. Okay, so let's see one by one. So the test summary report identifier, it means every single document. If you see so far, every documentation, for example, like our test case, right? Every test case must have the unique ID. So this is not only for test case, for every documentation. Even our test plan also will have unique identifier. But since for your assignment, you are just producing one version of test plan, okay, because we are not going to review, we are not going to come up with the second and third version, or so we don't include the unique ID there. But every documentation will have the unique ID, like how you are going to do for your test plan, test case. Okay, so the same thing goes to the test incident report. For every incident, we have its own unique identifier. So even for summary also, we will have that, because there is versioning can happen. So that's why every report will have its own unique ID or identifier. Okay, so this will be easy to identify which report or which testing or which testing level. Okay, then we have the summary. This summary will be for the overall. Okay, so this will identify all the relevant support materials which will be needed for the testing which we have done. Okay, especially when we are having different versioning or different release of the software. Okay, and then this also will identify the versions of any external package which we use in the testing, and also how many cycles we have done. Okay, other than that, to summarize the entire test item, test environment, and any other reference. Okay, then the third one is the variances. So when we said we want to report our summary, our testing. So before you start your testing, you have produced your test plan. Okay, whatever you plan to follow for your testing, 100% you have planned it, and then you have documented. So your test plan is the proof. Okay, so during the test execution, you have the test log to keep track of each test case execution happen, and in the between of this test execution, whenever there is any incident happen, you produce test incident report. Okay, so from that 100%, some percentage has been changed due to this incident. Okay, so your test incident report just now, that is the proof of what incident happened. So when we said test summary report at the end of this testing, it's actually going to talk about where the changes part happened. So it means from what you have planned in your test plan, you could not follow 100%. So let's assume 20% during that execution changes happen due to any unexpected incident, as what you have written in your test incident report. So you need to talk about the incident and what it has caused, and then where is the changes, and according to that, what you have done. So you need to also put together the proof or the supporting document which can support what happened. It means the incident happened, what impact it has caused, and then where is the changes happen, and how you actually overcome that. So the same thing goes like, remember in your test plan we talk about the risk, your project risk, your product risk. So the same thing here. So when there is anything happen unexpectedly, so how you control it, how you able to proceed with your testing. So these variances is to show the changes part happen from your 100% test plan. Can you just give me 1 second? So sorry, yeah. This is the problem. I my sore throat is not getting better at all. Okay. Okay. So this is showing the changes part happen because uh, as a management they will be questioning you. Okay, you have planned 100%, this is how you want to conduct the testing, but you could not achieve that 100% how you plan. Okay, so what happened? So you need to mention about what issue happened, where is the incident, what type of incident, how it is actually give the impact to your testing, and then how you able to control it. So all these need to be included in your summary report. Okay, so from that 100% test plan, where is the changes part happen? Okay, so then the next part is the comprehensive assessment. So this is the evaluation of the testing, the test execution, based on the test objective in our test plan. So this will be include the evaluation of test coverage, so total objective which you have mentioned in your test plan, what are the scope or what are the objective we want to cover and which we did not able to cover, and then identification of uncovered attributes. So in case during the testing schedule something with high severity happened, until it caused us could not able to cover everything, all the test item or the test scope which we mentioned. So we need to also talk about the uncovered attributes, or where is the test process changes happen. Okay. Then the following part is the summary of the result. So summary here, we need to report the overall status of the incidents. Okay. So here, since it's a summary, okay, it's not only about the incident. So we will include good and bad incidents. So normally, how well the testing was going on and which part is not good. So we will talk both of it as part of the summary. So we can put the total incident happen based on the severity or based on the priority, and also the incident based on the cost or the failure impact. Then other than that, we can also talk about the defect patterns. Okay, defect patterns are normally like the classification of the defect, right? What are the type of defect most has been faced during the test execution, what patterns. Okay, then any open or unresolved incident, so it means we already documented the incident happen, or maybe we have put in the defect reporting, has passed to the development team. When we said pass to the development team, it means the status will be open. So it means it's already open to be reported. But when we said unresolved, it means the development team is not yet settled with the incident. So let's assume there is something which we cannot complete yet in the end, at the end of the testing. Sometimes when the development team uh, request for any waiver, so this will be under the unresolved incident. Okay, so that will be about the summary of the result. Then the next part is the evaluation. So evaluation is more onto the testing objective assessment, which is the overall testing where if there is any failure happen, uh, overall quality of the testing. Okay, how we have planned in the test plan and compared to what happened in the reality. So we will do the evaluation of the overall. So this will be including the good and the bad news, whatever happened during our testing. So limitation here means any incomplete or partial functions or features. Okay, or if there is any drop of the features happen in the between of our testing. So for example, due to any defects, okay, or any changes of requirement, so there is some features need to be dropped at this particular testing level, for example. Okay, and then failure likelihood, this will be based on the risk, any high or medium risk cost during the testing. So good quality or any bad quality areas or the features. Okay, then the next part will be the summary of the activities. So summary of the activities will be cover all the planned activities and the changes happen. So planned activities means as what we have mentioned in our test plan. Okay, and then compared to what we have planned, what we have mentioned in the test plan, and if there is any changes happen to those. Okay, so this can actually disturb the resources For example, human resources, like how much the effort they have, we have planned, and then actually they have put, okay, and then the duration, the time. So all this will be part of the changes also. So for example, the time, like daily basis, weekly basis, how much time. For example, if there is any overtime of work happen, so let's assume due to any incident, okay, because of delay happen, now we have very shortened schedule. So due to that, all the staff, they actually need to work on extra time. So that will be actually what we need to talk about compared to what we plan, and this is the changes happen. So other than human resources, material resources also can be part of the summary we need to include if there is any additional resources has been added or needed. For example, maybe there is any issue happen, then we need to have any additional devices or anything. Okay, then other than that, the budget cost also. So what we have planned, and then what actually we have spent. So let's assume we have put the budget this much, but we use less, then it means it's good. Okay, but if we need to top up the budget in the between due to any incident, then that is something we need to voice out also. Okay, then, other than that, the variances and the reason for the changes. So, what can be the reason for changes happen here? Okay, so this can be maybe we can talk about changes from the project scope, or maybe there is a requirement or the design changes, which is the reason, or there is any defect which we don't expect to happen, or maybe testers or any people who is part of the project, they actually resign in the between. Then maybe the test environment. So anything which can cause the changes compared to what we have planned. Okay, so this is actually what we try to identify under the risk. When you list down your project risk, your product risk, this is what you are trying to see in the beginning. So you, when you plan, you want to be alert that in case if this risk happen, this is how you want to control it. Of course, for your assignment, I don't want you to be like doing too detailed, like a software requirement engineering things. Okay, because it's just part of the test plan, because I know that during your testing you might not face the risk. Okay, you might face if there is any changes happen in the requirement or in the functionality, but it is something still manageable. But as part of the test plan, you need to identify the risk, what can happen, and how you need to control it, because this can be the reason what can cause the changes during our test execution and change our test plan. Okay, then the last part will be the approval. So whatever story you mention in the test summary report will be still need approval from the respective parties. Okay, so they will go through your test plan, what you have planned, and then what are the incident happens, and then your test summary report to make it tally. So suppose the total up of your test incident report and what you mention in your test summary report must be tally with your test plan. So it means you still able to achieve or not. So that is the concern of our top management. Okay, then if everything is okay, then they will approve the test summary report for you to end the testing. Okay, so that's it for our test summary report. Okay, got it? Can understand how we can close the testing with the test summary report. Any questions so far? Everyone okay? Okay. So the next part of chapter 9 is the configuration management. I think that should be the last part of our chapter 9. Yeah. Okay. So when we said configuration management, okay, so throughout our project, software development project, this is not only about testing phase only, but when we said the entire software project, okay, we will be involving with many different phases. So testing is actually one of the phase. Okay, so in every phases, I think from the beginning we have talked that every phases in the entire software development life cycle, we will be producing different milestones, different artifacts, or anything which we will be producing. Okay, and if you see each of these phases, okay, and the milestone which we have produced is actually needed throughout the software development life cycle. For example, what we plan, what we propose in the first stage, okay, we will need it for us to have our requirement. And what we mention in the requirement, we will need it for our design. And what we have mentioned, what we have draw in the design, okay, that is what we are going to refer to come up with our uh, code. Okay, then at the same time, what we have mentioned in the requirement, that's what we are going to refer to plan for the testing and to produce our test cases. So if you see throughout the software development life cycle, until we will complete the development, we will complete the testing, and we will implement the system at the client side. Even after the client started to use the system, we still need all these milestones or all these artifacts for the continuous supporting or continuous service or maintenance after that. So throughout the software development life cycle, we need to maintain the consistency. When there is changes happen at one artifacts or one document, it can actually cause impact in other documents or in other functionalities or in the features of the system. So it is not easy how we actually able to maintain this consistency, because when there is changes happen in the client side, in their requirement, and if we did not do the changes in our documentation or in the working system, it means these two sides they are not tally. So we need this configuration management, which is a system engineering process to establish and to maintain the consistency. So when we said consistency, it means we have two things which we are comparing to see either they are consistent or not. So one side I have the product's performance, or the product functionalities or the product attributes. Product here means we are referring to the software, to the system, which is actually being developed and being functioning. Okay, so this is my right side. Okay, I have the software, how the software is actually performing, how the software is actually doing the functionalities, and how is the quality attributes. Okay, and on my left side what I have is all the artifacts or all the documentation or all the deliverables which we produce throughout the software development lifecycle. So, for example, not only requirement but also the design can be the test plan, the test script, test cases, test data, any software, any hardware, or any items, any information which we have produced for us to get this software. So, is my left side and my right side consistent or not? That is what this configuration management helping us to do. So, this configuration management can be done in a manual way or in the help of automation tool. Okay, so let's assume if our company is a small company, okay, and we are dealing with a small size of systems or projects, and we are dealing with very small team. Okay, so all this information we can still manage it in a manual way. It means we able to control it. But when it comes to a big size or very complex project involved with a lot of big people's teams and huge numbers of departments. So it will be a bit difficult to do the manual configuration management. So the company can actually get a tool which can help to do the automation configuration management or computerized way of configuration management. Okay, but when we set a configuration management or a configuration management process or tool, it is actually helping us to establish and to maintain the consistency on the right side, which is the product performance, product functionalities, and the attributes, with the left side, which is all the information, all the items, or all the documentations, artifacts, whatever we have produced throughout the software development lifecycle. If these two things or these two sides they are not tally, it means what the client said is not what the client get. What the documentation mentioned is not what the software is doing. So if these two sides they are not tally, do you think the client will be happy with your end product? Do you think your project is success? When these two sides they are not tally. So let's assume I use an example of your project 1 and your project 2. Maybe you can understand it much more clear. Your project 1, all of you have submitted. Project 1, you have your proposal, you have your chapter 1, chapter 2, chapter 3, and chapter 4. Chapter 1 is the introduction, then follow with your literature review, follow with your what is that? The requirements, the methodology, and then the design part. Okay, so this is your project 1. Then you are going to come up with your project 2, which will be the development and then your testing, and then your conclusions. Okay, so if my project 1 and project 2, they are not tally what you have proposed, what you have say in your requirement, in your design, is not what you have come up with. It means it's not what you have developed. Do you think your supervisor will pass you? When there is no consistency in your project 1 and project 2, do you think you will pass your project? Yes. Okay, you will never pass because what you have proposed is not what you have produced at the end. So the same thing goes to this configuration management. On my right side, okay, I have the end product, and on my left side I have all the items which I have produced for me to get this end product. So what I have mentioned in the documentation, if it's not tally with what the system is doing at the end, it means there is no consistency. So when there is no consistency, it means our project is a failure because the software is not doing what the client said. It's not functioning as how it supposed should be. Okay, so when we said we want to maintain this consistency, we need to manage with the configuration management. So a complete configuration program, it means like a tool, it will include the features for the storing, for the tracking and updating of all the system information on the component, on the module, subsystem, and the system basis. So it means every level or every stages we are working on throughout the software development life cycle, it will help us to do the establishing of these items, how we can store it, how we can track it, how we can update to make sure that they will be consistent. So for example, my SRS and my SDD must be consistent. What I mentioned in my SDD, it must be consistent with my source code. What I mentioned in my SRS, that is what I need to test. So it must be tally with my test plan. It must be tally with my test cases. So all these items, we must track them. So we need to make sure that we able to store all these items, we able to track and we able to update every time when there is changes happen so that we can maintain the consistency. Okay. So this will be the activities involved. When we said configuration management, it means it will help to identify and define the items in the system. So items here means it can be anything like your requirement, your design, your test case, test data, test result, everything. Then it will be also deal with controlling the changes of this item throughout the life cycle. So whenever there is changes happen, it can able to control the changes. Okay, and then it can also handle in recording and reporting the status of the item and also the change request. So whenever the client change anything, they have requests for changes of requirement or functionalities, features. So we must able to record and report the status. Is it something approved? Is it rejected? Is it still pending? Is it something able to change or we must not do the changes? So all this
There's two
need
more
to be
structural diagrams.
report accordingly. Then it can also help to verify the completeness and the correctness of the items throughout the software development lifecycle so that we will not miss out anything. So correctness and the completeness will be very important. So configuration management normally we will start to do during the project planning phase. So it's depend when the companies are handling it in a manual way or in the automation way. So we will start during the project planning itself so that we able to use this configuration management for us to start to store and keep and take care of all the items which is needed for the software project. Okay, then it will be also accompanied with the test item transmittal report. So there will be one more template which I will discuss about the test item transmittal report. So normally because we are dealing at the software testing phase, right? So we have seen all the template related to the software documentation. So test item transmittal also is part of the report which we need to produce. It means as a software testing site. Okay, so that one I will show later. Okay, the process of the configuration management. Okay, sorry. So the process of configuration management, okay, where it will involve with the planning and the management. So it means it will help to plan the guideline for the product design or the requirements, allocation of the responsibilities of the people involved, tools and the procedures which we need throughout the software development life cycle, and then identify any third party requirements, especially like different stakeholders or any auditing parties or any standard organization for any auditing and review process. Okay, then the second process will be identification. So this one is to set the baseline and to identify all the assets configuration or all the items configuration. Okay, then the third one is control. So this is to maintain the configuration control, change request and the execution of the changes happen to the system and also to the documentation. So every time when there is change request happen, there is need to be done any changes, we need to make sure that the changes happen in every areas where it is involved. For example, if changes happen in requirement, we have to make sure that we update the design, we update the source code, we update our test plan, we update our test case. We also need to make sure that wherever all this requirement can be impact, we need to make sure we maintain the consistency on the changes happen. Okay, so that our documentation and our system will be in a consistent. Okay, then the status accounting. So as what I've mentioned, every time when there is changes happen, okay, we need to have a proper status accounting so that we know what is the latest status or what is happening in the software development life cycle. So whenever there is any changes happen, any requests happen, so we need to know who is doing the changes, who is requesting for the changes, when it's happened, how it's happened, is it approved or is it not. So all this need to be keep track. Okay, then the next one will be the verification or the audit. So normally every single item which we deal throughout the software development life cycle will be needed for the verification purpose or for the auditing purpose. So we will do the verification on the items, on the process, on the control, and to make sure that we are managing all these items and we are producing our end product according to that. Okay, so this will be the 5 process of the configuration management. So as what I've mentioned about the test item transmitter report, okay, So this is our last test documentation template. So this is also using the IEEE 8 to 9 standard. So test item transmittal report means a report which we need to prepare every time when there is changes happen on our test items. So it means whenever, if you see in your test plan, right, you have identified the functionality of the system as the test item. Am I right? So so every time when those items is having any changes due to the requirement changes from the client, which can cause the changes on the test item, so we will need to do the reporting so that we will not miss out anything. So this will be identify the test item based on what is the current status, based on the location where the information able to be located, and what are the changes happen, and also the status, the dates, and the approval. So if you see, the template is a very simple template. So transmittal report, as how I mentioned, every report will have the unique identifier. So every time when there is any changes is happening, so we will have unique identifier to keep track. Okay, then what is the transmitted items? So it means which test items or which requirement, which test case is actually affected from there. And then location here, normally like in the system, in the folders, such where is the part where the items can be identified. And then status is very important to know either these changes has been approved or not, because we cannot simply do changes on our side when the changes is not actually have been done the another side. Okay, so we need to know the status and also the approval. So we need to also mention is the changes in our test item is approved or not, because sometimes we cannot simply do any changes based on what the client asks, because it might be impact our testing process due to maybe resources, uh, because of our budget, because of our timeline. So because of that, we have to make sure that we get the approval whenever there is any changes happen first, then only we can confirm it. Okay, so every test item, whenever there is changes happen, so we must produce this report. Okay, so that we can make sure that throughout the software development life cycle and the testing phase, we will maintain the consistency. Okay, so that's about the configuration management. So the last part is just some additional things about the tools for supporting the testing. So when we said supporting the testing, it can be under the test management areas or test automation areas or bug or defect tracking areas. So you can see the link provided. I already include some links for you to go through some testing related tools. That's why I always said testing tools is not only about running the test case, but it can be for other purpose also. Okay, then tools for support testing, where it can be helpful for managing the requirements, the configuration items, any incident or any unexpected incident happen, or any test where. And then it can also help to provide information on our testing activities and the test execution tools interfaces. And it can also maintain the traceability between the testware. It means like our softwares. And then this is just example based on each of this area. So under test management, we can have requirement management tool, configuration management tool, test execution, we can have static testing tool, static analysis tool, review support tool, and then followed by test design tool, test execution tool, and under the tracking tool, we can have the incident management tool. It means like the bug or defect management tool, and also performance monitoring tool. Okay, so this is the end of our chapter 9. So I have completed all the 9 chapters for our software testing. So the balance will be chapter 10 until chapter 12, which will be more to software quality assurance. So chapter 1 until chapter 9, I already covered, and I already done with the software testing side. So the last 3 chapters, chapter 10, 11, and 12, it will be more to software quality assurance. Okay, so that's it for our chapter 9. So we need to discuss tutorial 8, and also we need to discuss tutorial 9. Tutorial 7, are we done all the questions? Can I confirm? Tutorial 9. Sorry, tutorial 7. Tutorial 7 was about the test case, about the test readiness review. Are we done? Okay, so we should start with the test tutorial 8. Okay, so tutorial 8 was, chapter 8 was about the test data generator. I have discussed 4 different types of test data generator. Then I have discussed about the test data. And then we also discussed about the test environment readiness. Okay, so let's discuss. Question 1, describe the different types of test data generators. So what are the 4 different types of test data generator? You can refer back to your chapter 8 slider. I have discussed 4 different types of test data generator. What are the 4? Okay, so we have the random test data generator, the goal-oriented test data generator, the pathwise test data generator, and the last one is the intelligent test data generator. So I'm not going to go to one by one again, but I will just say briefly. So random here means based on the name, you can see the test data will be randomly generated, okay, without following any specification or any particular requirement, okay. Then goal oriented and pathwise, they are actually both uh, generate the test data based on the control flow graph path. Okay, goal oriented, it is not wise enough, but it will it will be generating all the test data for all the path. Okay, but pathwise is actually able to generate the test data based on the specific path which we want to test. Okay, then the intelligent test data generator is actually able to analyze the source code straight, okay, and then it can able to generate the test data based on the source code. So that will be the 4 types of the test data generator. Okay, when selecting test data, there are some questions to be asked for the test data requirement. So this is like a general question. So what are the requirements? So when we want to select the test data for our testing purpose, what are the questions or what are the things which we need to check first as part of the test data requirement. So, in your test plan, under the test environment, test data is one of the items, okay, where you actually need to prepare the test data table, okay, for the data, valid data, invalid data, which you are going to use for your testing purpose. So, what are the questions or what are the things you need to check for you to select the data? How you are going to have this data? What was the first thing we discussed on chapter 8? The first thing before we talk about these four test data generator, what was the first thing we discussed? Check on your slide. Test data generation. Okay, what are the type of test data we have? I think we talk about three different type of data. The, yes, what is it? Real data, then check on the slide. Before we talk about the four generators, okay, random data, real data, is it artificial data? It means the random data, right? Then the fixed pool data, correct? Okay, the first thing, normally as part of test data requirement, the first question is what data we want to use. The first question. When we said what data we want to use means, are we going to use the real data or the artificial data? It means randomly generated artificial data, or we want to use data from a fixed pool. Okay, when we set real data, it means we use the data from the daily transaction, real data. Okay, and if we set artificial data, it means it will be randomly generated similar to the real data, just for testing purpose. And when we set fixed pool data, it means we as a software testers, we have the database where we have stored all this test data from the previous testing. So we want to use the fixed pool data. So this will be the first question. What data we want to use? Are we going to use real data or artificial data or fixed pool data? So that can be the first question. So let's assume if we say we cannot access to the real data and we want to generate the data, it means artificial data. The second question we can ask is what test data generator we want to use. Is it random? Is it goal oriented, pathwise, or intelligent? So the second question is more onto the generator which we want to use. Got it? So let's assume if the test data, we said we want to use the real data. We don't want to create the artificial data. We want to use the real data. So the question will be, do we have access to the real data? Is the real data is easy to use? Because real data means it's going to be a lot of issues to deal with. So is the real data suitable for our testing purpose or not? So when it comes to real data, we can ask that question. So let's assume we don't want to use real data, we don't want to use artificial data, we have a fixed pool. It means we have a storing of data from previous project. So we can ask if this data, because when we said from previous project, it cannot 100% fit the requirement. Am I right? We still need to do some modification. So the question we can ask here is the fixed pool data suitable for our testing purpose or not? So it means how many percentage it can fit our testing purpose, or what are the modification we need to do for our testing purpose. Okay. So these are the type of questions which we can ask for us to fulfill our test data requirements. What data we want to use, okay? What generator we want to use. If it's a real data, do we have the access to the real data? How about the amount of data? Okay, and if we said we are using the fixed pool data, is the fixed pool data is suitable for our testing purpose, or how we want to do the modification on the fixed pool data? So all this will be part of question which we need to ask when we want to select the test data for our testing purpose. Okay, got it? Can understand what is meant by some question to ask? Okay, can we continue with this question first before we move to the test environment? Okay, so the next one is analyze the challenges in using production data. So when we said production data, it means we are referring to the real data from the daily production, from the daily transaction happen. We have the real data being stored. So for example, like TAI-UMT, they have stored all these students data, staff data, all these courses, programs, result, fees, and everything. So they have a production data, the real data, which they have been keeping for how many years now. So let's assume for your testing, you want to use this real data. What can be the challenges we need to deal with? What can be the challenges in using this real data? Hard to collect means, what is meant by hard to collect? Is it like we will not able to get the access to use the real data because of the privacy? Is that what you mean? Okay. So real data, normally it's going to be the actual data, right? Real data, real. data about you, about me, about everyone. So it will not be easy to access to it due to the privacy of the data. So privacy can be one of the most critical challenge we face. Okay, other than that, what can be other issue, other challenges? What can be other challenges of using real data? How about the amount of data? When we sit production data, we are going to have a huge amount of data. How about this amount? When we say TAR-UMT real data, how many years they are having this data now? And when you want to use this data for your project, how it can be? Sorry, what do you mean just one? Let's assume you are using I mean sorry, you are working on TAR-UMT related project for your FIP. Okay, and then you want to use the real data which has been stored like more than 50 years of data there, for example. I'm not sure, I'm just saying more than 50 years of production data being stored in TAR-UMT database or server. So, do you think it will be easy for you to use that data for your testing purpose just because you want to have the real actual format of the data? Can you just take and use those data, that 50 years of data? Do you think it's easy to use it for your testing purpose? Never. It can never be easy because you have a lot of data, and for you to sort the data, it is one thing. For you to do the data cleaning, one thing, because there might be a lot of junk of data, because junk data, because the system is keep on changing, keep on changing requirement from 50 years back to now. So a lot of data might be empty that time, or might be junk data compared to how things are being validated now. So a lot of, how to say, like useless data they are there. So when you want to use the real data to do this cleaning of data, it's already a lot of things to do. So when we want to use this real data, amount is one thing, but to get the right sort of data is another thing, where you actually need to clean the data, you need to sort the data according to your own testing objective. Okay, and bias. Uh, what do you mean by this survivorship bias? In use real data, can we say based on the logic of the code and the error? Cannot detect errors that result in the failure of creation of the data.
Like Miss, the real data, right? They are
Data.
all at some point positive test case, right? All of them.
Uh, yeah, should be.
Yeah, so there will be, if we only use real data, I think there will be a
Mm,
lack of negative test cases because
Mm.
incorrect ones, invalid ones will not be saved
Yes.
in the first place.
Yes, correct. Okay, so if you see, when we said using real data, normally only the success function, it means the valid data which we use for the positive test case will be the one successfully go into the storing part, because we expect the invalid data will be detected by the system and it cannot go into the storing purpose. So when we want to use back this real data, we can only use the data, I mean, we can only use the valid data. So it might not able to cover our test coverage, because we can only do the positive test case but not the negative. So there will be actually lack of the testing coverage, where the negative part we still need to produce it randomly by ourselves. Okay. So this is just some challenges in using production or real data. Okay, so that's it about the data part. So the next part is the test environment readiness review. What is the importance of test environment readiness review? The guideline of the test environment readiness, and then the effect of the inappropriate setup of test environment readiness. Okay. Okay. So, question 3, explain the importance of test environment readiness review. So, if you see, we already discussed what is test environment. We already discussed test environment readiness, and we have discussed test environment readiness review. Okay, so before we discuss importance, what you understand about test environment readiness review? Everyone still remember what is a review, right? So when we said test environment readiness review, what is that? Can I just assume that the test environment will be ready without any issue, without confirming it? Can I just sit and expect that to happen? Cannot. So we need to have a proper review to verify that the test environment has been set up according to what is needed for our testing. Because as part of your test entry criteria, test environment must be ready for us to enter into the testing phase to start the testing. And this test environment is actually the list of all the software, hardware, test data, the network, the devices, equipment, tools, and everything what you have listed in your test plan. So when we say test environment readiness, it means how is the readiness level for the test environment. Is the test environment have been prepared, has been set up accordingly or not? If we have any missing hardware, missing software, have we purchased it? Have we installed it? Have we configured it? So all this cannot be just assumed that it will be done. So, as a testing manager or leader or the team leader, you might need to conduct the test environment readiness review, where you are actually trying to verify, you are checking if the test environment is set up accordingly without any issue for us to start with the testing. Okay, so now what can be the importance here? We want the first important here is we want to make sure the test environment has been set up accordingly, correct? According to what we have listed in the test plan and what we need for our testing purpose. So we want to verify that. Second one is we want to make sure that we able to fulfill our test entry criteria. Because if test environment is not ready, it means I did not fulfill one of my test entry criteria for me to start the testing. So if I don't do this review, what will happen? That will be the following question: the effects of the inappropriate setup of the test environment. Because one of the important here is I will need to know if there is anything inappropriate happen. If there is any missing, anything which is not functioning, anything which is not fit to work as a test environment. So this can be the importance of this review for us to confirm before we will start the testing. So if I don't do this review, what will happen? I might not identify this inappropriate setup happen. So when I don't review, I did not realize there is inappropriate setup of the test environment happen, automatically it's going to give me effects. Is it going to be positive effect? Do you think inappropriate setup of test environment can give positive effect for our testing? Never. It will only give us negative effects. So what can be the negative effects of inappropriate setup of test environment? What can be the negative effects when the test environment is not set up accordingly? What can be the effect? Unable to conduct the testing. Um, okay. Uh, maybe if the effect is like too severe, right? So it means like we cannot even start the testing. Okay. So it means we will not able to conduct the testing. Okay, let's assume we able to conduct the testing. What can happen in the between? First effect is yes, we might not able to even start to conduct the testing due to the inappropriate setup. But let's assume, unfortunately, it's still able to start, but something else happened after that. What can be the effects? Okay, if you see, it might cause any issues in the between of the test execution. Maybe our test environment give problems in the between of the test execution, which might cause any issues, any stopping of the testing, or any problem which can actually wasting our time to do checking, to do fixing, which can actually delay our testing schedule. Or what will happen is we might need to hold the testing due to could not achieve our test continuation criteria. Remember, we talk about the stability of the test environment can be a reason for us to stop, or sorry, for us to hold the testing. So it can disturb our test continuation criteria. So let's assume if we pass the test entry criteria, test continuation criteria, what can be other effect? It can cause inaccurate test result. So when it causes inaccurate of test result, can we achieve our test entry criteria? You know, test exit criteria, because we have mentioned about the percentage of pass test case, fail test case. So if we get inaccurate test result, is it possible for this percentage to be disturbed? So if the result is disturbed, automatically the possibilities to disturb the percentage of pass test case, percentage of failed test case can be disturbed too. So if this percentage has been disturbed, automatically it will disturb our test exit criteria, and we might not able to fulfill our test exit criteria, and in that case, can we conclude our testing? If we did not fulfill our test exit criteria, can we end the testing? Can we complete our testing? Cannot. So, if we don't do our test environment readiness review, it can really give a lot of negative effects to our test environment and also to our testing. So, this is why test environment readiness review is very important. Okay, so there can never be positive effects. Huh? Okay, the question 5, you can see the slide. Okay, I think we should have 4 or 5 guidelines. Okay, I have listed there, so you can refer to the guidelines on the slide. Okay, it's just like a general guidelines. We need to fulfill the test environment readiness based on the stakeholders requirement, and then how we can manage uh, the test environment when we are dealing with multiple projects, and then we are executing multiple types of tests, multiple test cycles, and then based on our resources. So that will be the guideline. You can see the answer given on the slide ready. Okay, so that's it for our tutorial 8. Any question before we move to tutorial 9? Okay, okay, so tutorial 9 is for the chapter 9, which we discussed just now. Okay, so defects I already discussed last week. Okay, so this question is about the defects classification and the priority. Let's see all the defects related question first. Huh? So we will discuss question 1 first, and then question 4, question 5, because the other questions is actually for the configuration management. I will discuss the last. Okay, so question 1, defect of software are described and handled by using defect classification and priority. So question A, list and describe all the classes in the defect classification. Provide one example for each class, what you mentioned in A, and then list and describe all the priority levels in defect priority. Okay, so how many classes we have in defect classification? Yes. Okay. So we will combine question A and B together. So for each of the class, when we discuss about the class, let's find one example for the class. Okay. So what is the first class in the defect classification? The first one in the defect classification. Showstopper. Okay. So what is mean by this showstopper? What type of defect? Not example. I mean, what is the description about this showstopper defect? What it actually do, what it can cause. Okay, so when we said showstopper, it means it actually can have high severity and it actually will stop our testing. Okay, and we might not able to continue with our testing. So normally, what can be example of showstopper defect? It should be related to the, when we said it's stop the testing. Normally it will be related to the requirement to the functionality. So the defect is actually disturb the functionality of the test of the system, and then we cannot continue with the testing of the system. Okay, and another important thing is when we said showstopper defect, we as the testing team, we don't have the solution. We cannot solve this type of defect. So it should be related to the development team where it involved with the coding of the system. So when we say the function is not able to be tested, it means it is something to do with the coding issue. So when it's related to the coding issue, we, the testing team, we don't have the solution. So any example related to the functionality. So let's assume uh, we have login function, and this login function always be the precondition test case for other functionality. So even though we give the correct test steps, we give the correct test data, but we don't get the actual result as what we expect. So this can be due to the coding issue. So we as the testing team, we don't have the solution. So what will happen? It will stop our testing. And since we could not pass our precondition test case, automatically we cannot proceed with other test case. So in that case, we must report this back to the development team so that they can do the fixing and they can uh, let us to continue with the testing after the resolve happen. Okay, this is showstopper. The second one, the second class after showstopper, critical. Okay, so how about this critical? What is mean by critical class? Are you sure? Critical is low severity. Is it low, very low severity compared to showstopper? No, low normally will be for the non-critical one. So critical here is actually still have a high severity. Okay, it is actually stopping the testing, but the difference is we as the testing team we have the solution. It means when we as the testing team we has the solution, it means it has nothing to do with the coding issue, because only when it's related to the coding we cannot fix it by ourselves, but the development team will be the one to do that. So when we say critical, it is still critical, it's still high severity, but the difference is we the testing team we able to solve it and then we can continue with the testing. So what can be example of critical defect where we the testing team we able to fix it? Something related to our side, it means due to something like for example test environment issue, test environment issue, test data issue, testing tool, or any software hardware which is not support the testing accordingly. So anything to do with our site, it means we cause the defect. Okay, it has nothing to do with the coding. So we as the testing team we able to fix, like for example if it's something to do with test environment, something to do with testing tool, we cannot blame the development team, but it's actually your part. So you should be the one have the solution, even though it is stopping the testing, but it has nothing to do with the development team. So you have to find the solution, you fix it, and then you will continue the testing. So this is something critical, something still have high severity because it's stopping your testing, but the solution is still internally by yourself. That is the difference. Okay, got it? The difference. So the third class after the showstopper, after the critical, we have the last one, which is the non-critical. So non-critical here is what we call as the low severity. So compared to showstopper or compared to the critical, this is considered the lowest one. Okay, so it is not something disturbing the testing. It is not stopping the testing, but it's still a defect. We know that it's a defect. So we still need to put as defect reporting, no matter how mild can be the non-critical defect. Okay, so the development team need to do the fixing. So what can be example of non-critical? Yeah, anything to do with UI. So any defect which you can see the on the user interface, okay, as long the defect is not stopping us from doing the testing. For example, it's just a UI defect, but a broken hyperlink, is it under non-critical? Broken hyperlink, is it under non-critical? Anything to do, like for example, we have the for example, like typo, or the images is not displayed out, or menu is not aligned accordingly, or the placement of the buttons, all this kind of thing is still defect. Okay, we know that it's, oh, this one is not popping out, this one is not showing out, it is still a defect, but it is not stopping us from continuing our test execution. It means when we do our test step, it is not disturbing. Okay, so it means we can still continue with the test execution, but whatever is it defect is still a defect, so we will still need to report it. So this type of defect is under the non-critical. But if there is a broken hyperlink where we could not continue by clicking the hyperlink, it means as part of our test tab, we have to click this hyperlink, and then this hyperlink is a broken, where we cannot get what we expect to see. Which classification is this? A broken hyperlink. Which classification is this? You know what is broken hyperlink, right? For example, uh, you want to test on the registration function, and then maybe the link for the registration form, or to submit the registration form, because submit button means there is a script of a link at the back, right? So when this did not work, which classification of defect is that? Is it still under non-critical? It suppose should be under showstopper, because it is stopping us from doing our test execution, and it is part of coding related defect, and we, the testing team, we don't have the solution. So even though it is a UI defect, but this type of UI defect, it's disturbing our testing. So in that case, it will be under the showstopper. Can understand? Can understand the difference between showstopper, critical, and the non-critical. Can I? Okay. So the next one is the priority level. So priority levels, we have discussed the three priority levels, which is the high, medium, and also the low. So this defect priority will be helpful for the development team to know which defect they need to do the debugging first. So when we set high priority, it means the defect is needed to be solved as soon as possible, because it is stopping our testing. Only after they have done the fixing, we can continue with our testing. Okay. Then when we set medium, it means the testing can be still conducted, but the fixing need to be done as soon as possible too, so that we can make it in a parallel mode. While they are fixing it, we are continuing with the testing, and then we can continue to test that part. Okay. Then when we set low, it means when it is actually not really emergency, not really high critical to be settled first. So after the development team has do the debugging for the high and the medium priority defects, then they can go to the low priority one. Okay, so that will be the three priority level in the defect priority. Okay, clear this first question? Okay, the next question is, what is the purpose of defect reporting? So, who is doing the defect reporting? Who is doing the defect reporting? Who identify defect? When we do testing, who identify defect? Of course, the tester. Because software tester is the one conducting the software testing and they will be the one detect the defect, identify the defect. So when we say that we need to do defect reporting, the tester will be the one responsible to do the defect reporting. And to who they are going to do this defect reporting? To who? When they do this defect reporting, to who they are doing this defect reporting? To developer, because the development team is the one actually able to do the fixing. We do the testing, we identify the defect, but the debugging will be done by the developers. So we need to do this defect reporting for us to describe what defect we identify, because developers will not be there to see what happened during the test execution. So if you don't do defect reporting, it will be difficult for them to understand what will happen, what happened, and how critical it is. They don't know anything. So, if you want the development team to understand what you have identified during the test execution, then you need to do a proper defect reporting. So, for every defect reporting, you actually need to describe the defect which you identify and how critical, how is the severity, which classification of this defect, and how fast you want the development team to fix it, which priority you put for this defect. You need to mention that in the defect reporting for you to report it to the development team. So this will be the proof of what you have identified during the test execution and what you have reported to the development team for the development team to do the debugging from their side. So if they don't do the debugging accordingly, it means you have done your part and they didn't do their part. And if you didn't do the defect reporting, then the blame is yours because you did not do the reporting of the defect you identify. And how come the development team will fix it? Got it? So this will be the purpose of the defect reporting, because you must produce this defect reporting so that they able to proceed with the debugging. Okay, got it? Can understand what is the purpose of defect reporting? So the defect reporting is coming from the testers to the developers, because testers will be the one identify the defect, development team will be the one fix the defect. Okay, so I think we will stop until here. So I have discussed question 1 and question 4. So we will proceed with the following questions. Okay, so that's it for today. So hopefully I will be okay by tomorrow and I will see you in campus tomorrow. Okay, so tomorrow we will see in the morning for your assignment. Everyone is sick, believe me. I don't know why. We are tested negative. I have tested negative, but I'm really, really not okay. Thank God, at least the fever get down. Okay, but I'm still not normal yet. Okay, please do take care of yourself, everyone. Okay, so hopefully I will see you tomorrow without any issue. Okay, so that we can proceed with your assignment progress, and I will complete the tutorial and start with our chapter 10. Okay, so thank you very much, guys. I will see you tomorrow.